Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so students, I think you have seen the previous lecture. We have started the chapter machines and we have discussed about up to the term mechanical advantage, and we have also discussed the other terms related to machine, that is load, effort. Okay, and we have been also seen the definition of machine, and we have seen that machine can act as a force multiplier if the mechanical advantage is greater than 1. It can act as a speed multiplier if the mechanical advantage is less than 1. And if it is equal to 1, the machine actually is neither a speed multiplier nor a force multiplier, rather it helps to change the direction of the application of effort. Okay. So with these previous discussions we have ended the previous class. So from today we will be continuing from the next term, that is velocity ratio. Okay. So without wasting much time, I will be quickly starting our class. Okay. So let us come to the term velocity ratio. So what do you mean by this term velocity ratio? First of all, let me write down the term velocity ratio. So what is the velocity ratio? So we have already studied the term mechanical advantage, isn't it? You know that mechanical advantage was the ratio of the load to effort. Likewise, velocity ratio, as you can understand from the term velocity, it is the ratio of some velocities, and it is actually defined as the ratio of the velocity of the effort. So this can be defined as the ratio of the velocity of effort to, I can say, the velocity of load. Okay, so it is defined as the ratio of the velocity of the effort to the velocity of the load. Fine. Now, so if I say that in a certain span of time, the point where the effort is applied, which may be regarded as the effort point, if it moves a certain distance, say dE, and within that same span of time, if I consider the point where the load is being overcome as the load point, if that load point also moves by a distance dl, so can I write it like this, that velocity of the effort will be then equal to distance moved by the effort in a certain time interval t by distance moved by the load in a certain time interval t. You know that formula for velocity is displacement by time, so I can write it like this, displacement by time. Okay. So as we are considering the displacement of the effort and the load point in the same time interval, you can consider both the times to be same as t, and thus this ratio turns out to be something like this, dE by dl. Okay, so this is actually defined as the ratio of the distance moved by the effort to the distance moved by the load, dE by dl. Fine. So this is the actual definition of velocity ratio. So you can write it like this, that velocity ratio Vr is equals to dE by dl. This can be also the mathematical formula. Okay. So as we have seen, mechanical advantage can have three values: greater than 1, less than 1, equal to 1. Similarly, velocity ratio can have also three values: greater than 1, less than 1, and equal to 1. You can obviously understand, if the distance moved by the effort within a certain span of time is greater than the distance moved by the load, obviously then the velocity ratio will be greater than 1. So if first condition is that dE is greater than dl, okay, in that case we can say that velocity ratio is greater than 1. Fine. In the second case, if we say that dE is less than dl, we can write it like this, the velocity ratio will be less than 1. And the third case is that if distance moved by the effort and distance moved by the load are both equal, then d will be equal to dl, and in that case the velocity ratio will be equal to 1. So just let me remind you, if velocity ratio is greater than 1, as in the case of mechanical advantage, this kind of machine will act as force multiplier. If the reverse is the case, less than 1, then it acts as a speed multiplier. Okay, speed multiplier. Fine. And if I say that the distance moved by the effort and distance moved by the load are both equal to 1, so that is the third case, that is dE is equal to dL, then you can easily write that the velocity ratio will be equal to 1, and in that case the machine neither acts as a force multiplier nor a speed multiplier, rather it only changes the direction of the application of effort. So I think the concepts are clear, the ratio of velocity ratio, the one term velocity ratio, and as in case of mechanical advantage, this is also ratio of two similar quantities, hence velocity ratio will also have no unit. Fine. So I think the terms velocity ratio and mechanical advantage are quite clear. These are important terms regarding this chapter. So please be careful. If you have not understand, please go through the video once again. I think the concepts will be clear. Okay. Now let us quickly move on to the next term. After velocity ratio, we will be coming on to the next term. What is the next term? Next term, let us see. Okay. Next is, after velocity ratio, we will be saying, we will be discussing about is input work or work input. So what is input work? See, input work you can define this as, if we have said that the point where the effort is applied on a machine can be regarded as the effort point, isn't it? So when a force is applied at the effort point, that is, you can say a force is applied, that is effort is applied at the effort point, then the effort point will have a certain displacement, isn't it? And we know that when force is applied at a certain point and that point gets displaced, then we say work has been done. Similarly, when effort is applied at the effort point and the effort point moves to a certain distance, then that kind of work is said to be input work. So input work can be defined as distance moved by the effort point into effort. So we can write this as work input equals work input work equals to effort into displacement of the effort point. Displacement of effort point. Okay, effort point. Fine. Okay. Next term is the output work. So what is output work? I think you can guess from the definition of the input work that we get the output at the point which is called the load point. Okay, so simply output work will be load into displacement of the load point. Displacement of load point. So this is the output work. Sorry, it's the output work. Load point. Fine. Okay. The next term that we will be discussing, so you know that the SI unit of work is joule, so definitely output work or input work will both have the units called joule. Now the next term is efficiency. What is efficiency? Efficiency, it is generally denoted by the letter eta. This letter is called eta. ETA. This is a symbol. This symbol is named as eta. Okay, name of this term. Efficiency can be defined as the output work by input work, or rather you should say useful output work. Okay, so efficiency can be defined as the output work by input work. Okay, input work. So this is the definition of the efficiency. Now remember one thing, it can be also stated as, this can be also equal to as you know work and energy are the same thing, so we can also say that output energy by input energy. This can be also the definition, input energy. Okay, also we can define this as efficiency as output power by input power. So we can define efficiency in all these ways. Okay, and efficiency can be expressed in decimal or fractional quantities. Also it can be expressed in percentage. If we just multiply these quantities by 100, then we will obtain the efficiency in percentage. And you know that, okay, so efficiency, I think all of you have heard efficiency of efficiency of machines. Various machines have various efficiencies. The more efficient the machine is, the more useful it is. As because the more efficient the machine is, definitely the loss in energy will be less. So we will be getting more useful work if we use a better or more efficient machine. Now there is a slight expression we can derive from this expression for efficiency. Let us just come to that derivation. So efficiency are defined as the output work by input work. So from this expression or from this definition, you can get a relationship between the efficiency, mechanical advantage, and velocity ratio of a machine. Okay. So what are those relations? What is that relation? Just let us have a brief discussion about that. Okay. So how can we correlate these three terms? See, we know that efficiency eta is equal to output work by input work, isn't it? Now you know that okay, output work is equals to effort load into distance moved by the load. So this is equal to load, so you can write it as L into distance moved by the load dl by effort into distance moved by the effort. So this is the output and input work. Okay. Okay. So we know that mechanical advantage is equal to load by effort. So you can say that this load by effort is equal to the mechanical advantage. So this term is actually mechanical advantage, isn't it? MA. Okay. And we can write the second term as like this. So you can say therefore you can say that efficiency eta is equal to mechanical advantage MA into, I can write this term as 1 by dE by dl. You can write it like this. Now what is dE by dl? This dE by dl is actually the velocity ratio, isn't it? VR. So obviously you can write from this mathematical expression that efficiency eta is equals to MA by VR, velocity ratio. So simplifying this expression, you can say that the mechanical advantage of a machine is equal to velocity ratio into efficiency. So this is the relation between these three terms. Okay, so please remember this definition, this expression is important, quite important, and this is also helpful while solving the numericals. I have uploaded the numericals related to this machine chapter in our channel, so you can view those. It will help you in clearing your concepts. Okay, so MA equals to VR into eta. Now, you know that efficiency for an idle machine is considered to be 100%, as because the energy that we give as input to the machine, that total energy is always obtained as the output. There is no doubt in it. So we can write for an idle machine, just let me brief it for you, that efficiency for an idle machine is always 100%. So for you can write for idle machine. Okay, you can write for idle machine. For ideal machine, we can say that efficiency is 100%. Efficiency is 100%. Efficiency is 100%. As because there is no loss of energy. The input, the energy that is given as input is totally obtained as the output. Okay, but for an actual machine, for a practical machine, so for actual machine, we can say that the efficiency is always less than 100%. Why? There are mainly 2 to 3 reasons. What are those reasons? Just let me denote the points. What is the reason? What is the reason that efficiency is not 100%? Reasons. What are the reasons? Just let me point it out. Okay. So you can say first of all the main reason for this is the presence of friction. Okay, so first point is that friction is present. So first point is that due to friction, this is the first point, due to friction. Okay, second is that the moving parts in a machine are not totally weightless. Moving parts are not weightless and not totally rigid also, and rigid and not totally rigid and not totally rigid. Okay, this is the second reason. And what is the third reason? If any string or spring is present, those are not totally elastic or fully elastic. String or any spring if present, not fully elastic. If present, not fully elastic. So these are the three main reasons for which an actual machine cannot have a efficiency equal to 100%. And from that point of view, I can also say that for an ideal machine, I can say that the mechanical advantage is equal to velocity ratio. But for an actual machine, the mechanical advantage is always less than the velocity ratio. And remember that for any machine, the velocity ratio always remains constant. The mechanical advantage can change with changing the efficiency of the machine, and you can all see this from this particular relationship. Okay, so today we will be stopping our lecture here. In the next class, we will be discussing about the levers, types of levers, and principle of levers. We will be discussing about those points. So till then, till the next class, please do study well, and if you have any query, please do mention it in the comment section. We will be happy to solve your query. Till then, thank you, take care, goodbye.